Welcome to the series of Azure ML Toolbox video tutorials. Today you will learn how to use Evaluate Model Control to evaluate the results of a classification or regression model with standard metric. We can use Evaluate Model to measure the accuracy of a trained classification regression as well as clustering model. Note that the evaluation matrix for each type of model will be different. So you just need to provide a data set containing scores generated from a trained model, and the evaluate model computes a set of industry standard evaluation matrix. This existing module was used and configured in score model video tutorial. So go ahead and watch that video tutorial to see how I configured each and every control in it. Now I will drag evaluate model control on the canvas. Typically, we connect score dataset output of score model to the input port of evaluate model. However, it is not necessary to connect output from score model always. You can also connect any dataset which contains a score column. And on the second input port, you can optionally connect one more score dataset. This feature is useful because you can easily compare results from two different models on the same data, or you might compare scores from two different runs over the same data with different parameters. We will first evaluate just one score dataset, and after that we will connect one more score dataset for comparison. And now run the experiment. Let's click on the output port of evaluate model and select visualize to see the evaluation results. As I mentioned earlier, evaluation matrix for each model will be different. Here we are using linear regression model. So the matrix are mean absolute error, root mean squared error, relative absolute error, relative squared error, and coefficient of determination. In general, the term error represents the difference between the predicted value and the original value. The absolute value or the square of these differences are usually computed to capture the total magnitude of errors across all instances, as the difference between the predicted and true value could be negative in some cases. This matrix helps us in measuring the performance of a regression model in terms of mean deviation of its predictions from the true values. Lower error values means the model is more accurate in making predictions. An overall error matrix of 0 means that the model fits the data perfectly. But in reality, there is no model whose predictions are 100% accurate. So if you get 100% accuracy, then something might be wrong in your model. The coefficient of determination is also a standard way of measuring how well the model fits the data. A higher proportion is better in this case, where 1 indicates a perfect fit. I have explained each of these terms in cross-validate model tutorial in detail. So in our case, relative absolute error and relative squared error are pretty low, and coefficient of determination is close to 1, that is 0.82. Therefore, we have a very good accuracy for predictions. As you can see, evaluate model can take two scored datasets as input and compare the results of both so that we can find out which model or which parameters suits the best for our data. So let's drag another regression model. I will select Bayesian linear regression model now. Let's just keep default parameters over here. Now I will train this model. So let's connect Bayesian linear regression and training dataset to train model. On this input, we have to connect untrained model, which is Bayesian linear regression, and here we have to connect a dataset. Here we will connect our training dataset from split data. Now we have to select a column on which we will train the model. I will select price column and press OK. Next, we have to score the trained model. So let me drag score model on the canvas. So let's connect train model and test dataset to score model. This is our test data. And finally, I will connect output of score model to evaluate model to compare linear regression and Bayesian linear regression. By doing this, we can find the best parameters as well as the best learning algorithm for our dataset. Now I will run the experiment. Now let's visualize the output results. We have got two entries over here. The first entry is for linear regression and second entry is for Bayesian linear regression algorithm. The coefficient of determination for Bayesian linear regression is higher than the coefficient of determination for linear regression algorithm. So this coefficient of determination tells us that Bayesian linear regression is more suitable for our data and gives us more accurate results. Also, all the error terms in second row are lesser than the first row. Therefore, Bayesian linear regression minimizes the errors and maximizes coefficient of determination. So this is how we can compare and analyze the evaluation matrix for different learning algorithms. If you remember, we did the same thing in cross-validate model tutorial, that is measuring the performance of the model. Evaluation and cross-validation are standard ways to measure the performance of your model. They both generate evaluation matrix that you can inspect or compare against those of other models. So if both of them gives us evaluation matrix, then which one to use? Evaluate model expects a scored dataset as input. However, cross-validate model expects an untrained model and a dataset as input. Cross-validate model will divide the dataset into 10 different folds and provides the evaluation results for each fold. Therefore, you will generate some number of models per trial. This will help you in finding perfect parameters for your learning algorithm. Cross-validate model will prevent you from overfitting the model. After that, train your model on all the training data with new parameters and then apply scoring and evaluation model on it. Keep in mind, machine learning is not about finding the best model. It is about finding the best parameters for the learning algorithm. Therefore, we have learned how to utilize evaluate model to measure the accuracy of a model or learning algorithm. Thanks for watching.